The year is 1054. A royal astronomer in China looks up at the sky and can't believe his eyes. In a place where no star should be, a blinding light suddenly appears. So bright, it's visible in broad daylight. This star remained visible during the day for 23 consecutive days. At night, it was so bright that shadows could be seen on the ground. But this was not a birth. This was a death. 6,500 light-years from Earth, a massive star had reached the end of its life. Its core collapsed in an instant. A shockwave so powerful burst outward that the star's entire outer layers were hurled into space, and that explosion is still continuing. To understand how a star dies, we first need to understand how it lived. Stars are essentially enormous balancing machines. At their cores, a constant nuclear fusion reaction takes place. This energy creates an outward pressure, while the star's own gravity pulls everything inward. The perfect balance between these two forces is what makes a star a star. But this balance doesn't last forever. The fuel runs out. As hydrogen depletes, the star begins burning helium, then carbon, then oxygen. And finally, only iron remains. Iron fusion doesn't produce energy, it consumes it. At this point, the balance breaks. The star's core collapses inward in a fraction of a second. The energy released is so enormous that the outer layers are violently blasted outward. This is a supernova. The energy released in that single moment was greater than everything our sun will produce over its entire lifetime. So what do we see when we look at that point in the sky today? Red, blue, orange, and golden glowing filaments, spread across space like an enormous tangled web. The Crab Nebula now spans 11 light-years across, growing larger every single day. At 3.4 million miles per hour, and it's accelerating. NASA recently did something incredible. The Hubble Space Telescope photographed the Crab Nebula in 1999. 25 years later, it turned back to the exact same spot and photographed it again. When you place the two images side by side, the difference is visible to the naked eye. The nebula has grown significantly. Now let's return to the very center of the explosion. The collapsed core of the star remained behind. Gravity was so powerful that electrons and protons were crushed together, converting into neutrons. What remained was a neutron star, just 12 miles across, yet more massive than our sun. A teaspoon of neutron star material would weigh approximately 1 billion tons. But this neutron star is no ordinary one. It's a pulsar. It completes 30 full rotations every single second, blasting radiation into space with every turn, just like a cosmic lighthouse. When this pulsar was discovered in 1968, it shook the scientific world, because the existence of neutron stars was still only theoretical at that time. The pulsar inside the Crab Nebula became the first solid proof of that theory, and today it continues to power those glowing filaments, keeping that magnificent nebula bright. A star that died 1,000 years ago, still producing energy, still radiating light, still expanding. For the universe, this was not an ending, it was just another beginning.